We are going to show some digital video, and we're going to go into talking about what we're doing specifically around deep learning and some of the visions and direction, and specifically what we're actually doing to figure out what images you as a consumer have a cognitive reason to click. So here are some three major crossroads, and we're really at an incredible time right now when it comes not only to just computing power, but deep learning. But fast and big data is obviously a big buzzword, but for video, that is a very critical component. So clearly we're going to talk about what specifically Infinigraph has gotten involved around with deep learning and really understanding the reasons why humans interact with content. And so that's one of the things we're going to talk about. There's some machine intelligence, but TensorFlow we're very excited about, OpenCV, which has been around for a long time, Baidu, which is a sentinel moment in this industry today. And then GPUs, and these are like embedded GPUs. This is the Tensor Processor GPU. This is the open source platform that Facebook came out with. It's optimized for Tesla, the Tesla cards, NVIDIA. And we were very lucky that a guy named Tony had actually created a custom 8 GPU box that we're using today. And this is an 8 GPU TensorFlow box that we're doing some really cool stuff with. So let's talk about the video explosion. I know I went through that really quick. But this one here is that's what's happening and why we got into the business. And I just need to show of hands, who's played a video in the last week on a digital device? Everybody. It's ubiquitous. And what's cool about video is it's really the ultimate communication tool, because humans, we are living in video. My eye is made to see video. I'm doing a video of you right now by humans, which is pretty incredible because it's a pretty killer sequence of a Game of Thrones video. And we'll be talking more about why and how we figured out why these were the images that people resonated with. And that's the exciting part. But here's some really live examples of Game of Thrones, Star Wars, more Star Wars, that we pre-process video. We're going to talk specifically about how do we go about pre-processing video at scale. But I'm actually showing you the end product. And all of these videos you're looking at here, and this one in the middle as well on mobile, got over 100% improvement. That's phenomenal. Video creates a massive data pipeline. So that's the first component which we talked about, that to create a successful deep learning company, you really need to have an incredible data pipeline. And obviously like location, strings, and all of this data is literally flowing in at once. And that is a hard problem, especially for publishers. They're just having a hard time getting it out on the web or getting out through their feeds. Now, what do you do with it? So there's a lot of information, and that's why we call it the data pipeline opportunity. But there's a whole plethora of other data that we're very excited about. And this is around the human actions. So remember I was talking about the fact that humans would touch or engage with the video. Well, for us, that enables us to explicitly tell us which image in the video was most relevant to that audience. So we're able to pour that information back into our system and say, well, let's find other images like that and identify that, and that becomes our training set. And that's where that becomes the learning aspect of what we start off with. And then that's the fact that once we know that someone's taking an action, that means relevance. So that we're when you're thinking about hundreds or millions of people taking action on visuals, that crowdsourcing has a huge amount of value every day to images. And the question is why are those images relevant to us? And in the last literally 20 years, it's been a guess. Well, we literally want to change that with deep learning so that it's not a guess. It has high probable that you will then be engaging on. And our product's called KRAKEN. And it's ostensibly the first video deep learning technology. And our whole mission as a company is to find the best image in a video sequence. And so here's an actual example of a video that we process. And I don't know, here's Warriors fans. I'm a Warrior fan. So depending upon which image, let's say if you're a Cleveland Cavalier or you're a Michael Jordan fan, depending upon which visuals show, your brain actually lights up. It's just the fact. So whichever image that you're going to engage with or you have an emotional response, we want to know that. And what's cool about what we're doing is we're actually, with the fact that we're breaking apart the video and creating high quality images or sequence of them, literally allows us to create a visual story. And you'll see the end product, which is I'm going to show a towel base. And so everyone in the room is going to potentially gravitate towards one sequence or one set of images in this video body. And that's the cool part, is that this is where it really gets interesting. Because now we're saying, well, it's not just one image, but a 3-minute clip has 5,400 frames. That's a lot of information. So thinking about, wow, okay, that's 5,400 frames. Well, which frames are most relevant to you? And that's the art of storytelling, is being able to, how do you bring that information together? And then our job is we want to figure out which ones are you not only willing to engage with, but create a probabilistic equation around that and say, if we were to show you another type of image, would you engage with that as well? And that's really where the fun part begins. And this is a cognitive response I was talking about. So this is the breakdown of all the images, and the one on the right is a default thumbnail, but all of these images that you see here are the ones that are deemed as having a high probability of someone engaging with. So it could be 50, 100. So as soon as we have a set of those are the ones that are put out to the audience. And then we quickly do what's called an A/B test. So we'll do a 90-10 split. So 10% of traffic go to the default thumbnail and 90% will go to KRAKEN. So we'll quickly find, and that's the aspect I was talking about, where we're using the audience to help improve our system. So very similar to how Google did they sent out road signs for doing the CAPTCHA, where they crowdsource people to identify. We're doing it on the scale of video. And so this is the low-cost approach. So one of the things is it's very expensive if you think about trying to run a convolutional neural net on thousands or millions of frames. And this is the entropy scale, which you'll be seeing here in a second. And what's cool about this is it allows us to quickly process massive amounts of video to get down to specific images and then be able to test those images across the audience. And that's part of our learning set. And then one of the things that's not interesting is sometimes there's good blur and there's bad blur, like if someone's running versus just a bad blur image. That's a very hard problem that we've been able to work out. But being able to segment those out, because at the end of the day, our customers don't want to see bad images or nonsensical images being shown. So we have to be very careful. And then there's simple things like grayed out screens or transitions, so you got to throw those out as well. And then, as you know, video, when you release video, not every video is viral, right? So when you release a video, it actually has a time to live. So many people will engage with it and it'll have so much traffic, and that's just how video works. There's too much of it. But you can see here the slopes here is that some video dies fast and some video dies very slow on a recursive basis. And then here's another example of where we're interested in faces, size of faces. Believe it or not, humans really like faces. It's baked into our reptilian mind. So this is interesting to us as well, as we want to detect, well, is there a face present? And then how large is the face? And now I've blurred out a few things that we don't show people, but this is a side-by-side element. So here is a collage of what's called a pattern where we're segmenting patterns. And this is very common. And basically you're wanting to group light-based images. So, and then the cool thing about that is that you're able to then group light-based images, so that becomes a cluster or a view of clusters of what people would resonate with, because you're grouping images that are relevant. And I was wanting to put this out here in Google Vision. We're very excited about this because this is some of that open source. And if you don't know this, Google has an API, so you can pump in images into their system and they will give you classification back, and it's unbelievable. And that's what I was meaning about this as a sentinel moment for this industry, because it's really changing, and it's just the degree of information that they're able to tell you the type of animals, and now they're coming out with what's called emotions, where they can actually tell you what emotions people have. So this is incredible, and it's an API driven. So we're talking about really democratizing a technology that in the last 5 years was really almost inaccessible. But this is direct examples of being able to bring in streams and process it. Now for us, and this is Facebook, which is another thing which I just wanted to show. And I always like to point out that their Facebook is actually picking up the shadow of the bicycle rider. You can see that. So it's a little interesting that the image classifier is treating your shadow as something real. And so it's not perfect, but this is actually a three-dimensional or a 3D virtual reality real-time image classification. They didn't disclose what kind of compute power that was used to pull this off, but it definitely shows some of the direction, and we're excited to be potentially embarking in that direction as well. So now we're at the point where what's next with video deep learning. So we talked really quickly about, image object classification, but here there's the big opportunity is now not only could identify what's in, I here know about convolutional neural nets, the advancements around that and this free software out there is just phenomenal. And the ability to mathematically describe an image is a big deal. I'm very bullish of TensorFlow because of the community. It's got a whole year ahead of everyone else. So what they've distributed and built out is phenomenal. And there's so much stuff that's just free. But this is an actual flow diagram of showing the different layering. I just share that with you because I'm very geeky, and I like that because it is hard to actually figure out what's happening in layers. CNNs, and this is a toolkit you can download right now and run it. But who remembered War Games? Come on, be honest. So that was a very big deal movie for me. So what does that mean to us? So obviously that's very exciting that this is happening in our lifetime. But for us, we're looking at the scale of how many videos are out there right at this moment that are being interacted and shared with. So this is our AlphaGo problem of being able to analyze, process at scale millions of videos. And this is a real example of what's called a distributed array. So with different videos being placed in different places, perform differently with different visuals. So we were actually tapping into a regional effect. And that information is not only poured back into our system, so we're able to effectively create a reinforced deep learning solution where we're now utilizing that information to improve our algorithms. And so where we're going to go with this is the sky, and we're very excited about it. But that's what I described about the top images being recycled back in. We do think we're hitting an opportunity where we're actually doing a crowdsourced human intelligence, and we're using that for advantage. And that's very exciting. And that's my talk. So